Now let us see the reaction of sulfur dioxide with oxygen. So sulfur dioxide react with oxygen at high temperature. Sulfur dioxide gas and oxygen gas react with each other at a high temperature of 450 degrees Celsius in the presence of the catalyst called as vanadium pentoxide B2O5 to give sulfur dioxide gas. Fine. So this reaction is a significant reaction, the contact process of sulfuric acid manufacturing. Fine. So we'll see, let us balance the reaction here. So here on the left hand side 4 oxygen atom, on right hand side 3 oxygen atoms. So in order to balance here I put here 2. So here it becomes 6 oxygen. Yes, now here it becomes 2 sulfur. So 2 sulfur, here it is only 1 sulfur. So I balanced here with 2. So 2 sulfur is balanced. Now here 4 oxygen and plus 2, 6 oxygen on the left hand side and 6 oxygen on the right hand side. So that is balanced. So sulfur dioxide can react with oxygen gas to form sulfur dioxide. Now let us look at the bleaching action of sulfur dioxide. So bleaching means colored substances is making colorless. That is your bleaching. Okay. So bleaching action of sulfur dioxide is due to the reducing property of sulfur dioxide. Okay, so let us see how the bleaching action is done by the sulfur dioxide. Sulfur dioxide in the presence of water react with each other and form sulfuric acid and 2 hydrogen atoms. So 2 hydrogen atom is nothing but your nascent hydrogen atom. Okay, so 2H which is given in the bracket. So this bracket indicates it is nascent. Okay, so nascent means its a reaction is vigorous reaction take place. Okay, so the reaction is vigorous here. So nascent highly reactive hydrogen it is. Nascent hydrogen is highly reactive. Okay, so sulfur dioxide in the presence of water react with each other to form sulfuric acid and 2 nascent hydrogen atom which is highly reactive. Okay, now let us balance this reaction here. So here it is 4 hydrogen atom. So here it is 2 hydrogen atoms. So I balanced it, became 4. Now here 1 sulfur, also 1 sulfur. Now here it is 4 oxygen atom, whereas here also 4 oxygen atom. So it is balanced. Okay. Now this highly reactive nascent hydrogen, it react with the colored material. So here X is nothing but your colored material. React with the colored material and becomes colorless material. Okay. So color is being lost by the action of this nascent hydrogen. So how many nascent hydrogen? 2 nascent hydrogen. So 2 nascent hydrogen react with the colored material and make the colored material colorless material, that is XH2. Okay. Now this colorless material on standing for long time in the air, yes. So the atmospheric oxygen react with this XH2 and further it regain its color. Further it regain its color. Okay. So what happens? This bleaching action of sulfur dioxide is a temporary bleaching. That means the color is not retained. Okay. So the same bleaching action is also seen in the chlorine, in the case of chlorine. So there, when the substance colored material is reacting with the chlorine, what happens? Nascent chlorine, nascent oxygen is obtained. Yes. So as a result, there the color is permanent. There color is, so subsequent oxidation of the colorless material. What happened? The temporary whiteness of the substance is retained in the case of chlorine. Okay. So chlorine bleaching is permanent bleaching. Yes. So that is because of the presence of nascent oxygen. So nascent oxygen, as it is getting exposed to atmospheric oxygen, it is further getting oxidized and the colorless substance is getting oxidized continuously, so that the color that is colorless is retained for long time. So it's permanent bleaching. Whereas in the case of sulfur dioxide, the bleaching is not permanent, it's temporary. Why it is temporary? Because colorless materials on standing for long time in the atmospheric oxygen, they further get oxidized and they get colored. The color is regained there. Okay, they get color is regained. Fine. So that's why this bleaching action of sulfur dioxide is temporary bleaching. Yes. So here sulfur dioxide, its bleaching action is due to the reducing property of sulfur dioxide. Sulfur dioxide combined with water to form sulfuric acid and nascent hydrogen. This nascent hydrogen is responsible for making the colored substance to or colored material to colorless material, and the colorless material become XH2. So that means it is colored material is becoming colorless, that is the XH2. These colorless substances or materials on standing, yes, on standing is the color is regained, so that's why sulfur dioxide is acting as a temporary bleaching. So substances like wool, silk, then our fabric materials, then hair, yes, so all these can be bleached with the help of sulfur dioxide. That bleaching is temporary. Okay, so that's it all about your bleaching action of sulfur dioxide. Now let us look into the structure of sulfur dioxide here. So sulfur dioxide is one sulfur atom and two oxygen atom, and they combine to form SO2. Okay, so now let us look into the valence electron of sulfur and oxygen. So sulfur and oxygen both belong to 16th group. So the outermost shell contains 6 electrons. So valence electron is 6. So for sulfur it is 6, and for oxygen also it is 6. But oxygen, 2 oxygen atoms are there. So 6 into 2. So 6 into 2. So that gives you 12. So 12 plus 6. So altogether you get 18 electrons. So 18 electrons, valence electrons are present in sulfur dioxide. So now these 18 electrons should be represented in the structure of sulfur dioxide. So we know one sulfur atom and 2 oxygen atoms. So I just represent it here. One sulfur and one oxygen, another oxygen. Okay, now this 18 electrons should be represented over here. Okay, so I just put a bond here, one bond over here and another bond here. Okay, now one bond means 2 electrons. One bond means 2 electrons. So here also 2 electrons. So altogether 4 electrons are there. So from this 18, when I minus 4 electrons, you get 14 electrons. Okay, now this 14 valence electrons should be represented here. Okay, so let me represent here 1, 2, 3, 4, 5, 6. Okay, now here it is represented here. Now for this oxygen also 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, this is represented. But after representing all these valence electron, 14 valence electron, each element of this sulfur dioxide should get octet configuration, octet electrons. Okay, octet means how much? 8 electrons. So now let us check out whether it is having 8 electrons or not. Now look into this oxygen. So this oxygen 1, 2, 3, 4, 5, 6, 6, and here 2 electrons, 7, 8. So oxygen is getting an octet configuration. Got it? Now let us look into this oxygen. 1, 2, 3, 4, 5, 6, 7, 8. So this is also getting octet configuration. Yes. So what happens to sulfur? Sulfur 1, 2, 3, 4, 5, 6. Sulfur is getting only 6. It should get 8. So for that reason, what will I do? I just put a bond here. Yes, another bond. So the single bond will become double bond. So this bond I can put it over here or here. In either of the sides, I can put this bond. Okay, double bond. Okay. So now when I put here double bond, sulfur is getting octet configuration, whereas this oxygen, it is having 10 electrons. So for that reason, what will I do? I just remove 2 electrons here. Now it is getting octet 1, 2, 3, 4, 5, 6, 7, 8. Got it? Yes. Now, so this is the structure of sulfur dioxide. Okay. Now I said it before, this double bond can be replaced over here also. So for that reason, I just draw once more the structure here. So I put the double bond on the left hand side, on the right hand side I put the single bond, and as it is, the electrons I just represent here, because it is double bond. Here how many electrons? 4 electrons. So I represent it 1, 2, 3, 4. Because it is single bond, here it should come 6 electrons. Yes, and sulfur is having 2 electrons. Fine. So this is the resonance structure of sulfur dioxide. Okay, either we can write it in this form or in this form. Okay, so by writing the hybrid structure of sulfur dioxide, I represent it like this. I just put a dotted line. is the hybrid resonance hybrid structure of sulfur dioxide. Okay, either you can write it like this or you can write it like this. Fine. Now let us write the charge here. Okay, so I said you one bond is 2 electron. Yes. So in this 2 electron, one electron is shared by oxygen and another electron is shared by sulfur. Got it? So in the bond, one bond is 2 electron. So one electron of this bond is shared by oxygen and one electron is shared by sulfur. So likewise, oxygen gets 7 electrons. Yes, 1, 2, 3, 4, 5, 6 and here 7 electrons it gets. But valence electron of oxygen is how much? 6, right? Because oxygen is having one additional extra electron. Oxygen is getting the charge minus. Okay, now in the case of sulfur also we can see. So here 1 electron. Here in this bond also you get 1 electron. So in this bond also you get 1 electron. So altogether 3 electrons here and 2 electrons here. So 5 electrons. But valence electron of sulfur is 6. So it requires another one more electron it requires here for completing its valence electron. Okay, so it requires 1 electron. So for that reason it is getting the charge plus. Okay, so likewise wherever 6 electron is there, it gets minus charge. So here 6 electrons, so it gets a minus charge. And here it is completely, in this case oxygen 1, 2, 3, 4, 5, 6 electrons. So valence electron is similar here, is equal here. Okay, so in this oxygen also 1, 2, 3, 4, 5, 1 electron here and 1 electron here. So altogether 6 electron, that is equal to valence electron. So this is charges, this is having a charge, whereas here sulfur it is getting plus charge. Understanding? Yes. So that is all about your structure of this sulfur dioxide. And here in the sulfur dioxide, the hybridization is sp2 hybridization. So a double bond is seen. So this double bond is due to p pi d pi overlapping. Yes, p pi d pi overlapping. So that is the reason for the double bond. Okay, so that's it. So structure of sulfur dioxide is bend shaped. The hybridization involved here it is sp2 hybridization. Yes, it is having the bend shaped structure. Yes, and there is a double bond seen in the case of sulfur dioxide. Yes, in both the resonance structure, you can see double bond here. Yes, either on the left side or on the right side. So this double bond is due to p pi d pi overlapping of the orbitals, p orbital and d orbital. So p pi d pi orbitals are undergoing overlapping. So that is the reason for the double bond in the case of sulfur dioxide. So that's it all about your structure of sulfur dioxide. Now going to the uses of sulfur dioxide. Sulfur dioxide is generally used in bleaching the different types of materials like wool, silk, fabrics, etc. Okay, and it is also used as a disinfectant for the crops in agriculture. Fine. So that's it, the main chief uses of sulfur dioxide. So then completed your sulfur dioxide topic. Fine. So hope you understood. Thank you so much.